Hey guys, welcome to Young Minds versus Madhavi's Physics. We are dealing with Maths Marathon of Class 10 Mathematics, right? Day 9, Polynomials. As usual, let us see the theory behind the topic. So polynomial is an expression in x. Suppose if you say polynomial in x is an expression containing sum of finite terms of the form ax power n, right? Each term will be of the form ax power n and the number of terms should be finite. And here a can be real number but n is just a whole number. A is a real number and n is a whole number. As an example, if you observe like 2x, 2 is an integer. Here in place of n you have 1, x power 1. Okay, 1 is a whole number. Now 1 by 3x minus 4. 1 by 3 is again a real number, or what do we say, a rational number. Right, x power 1, 1 is a whole number. X square minus 2x minus 1, if you see the power here, the coefficient, whatever a is, right, it is 1, n is 2, here a is minus 2 and n is 1. Right, and here you can say that if you speak about a constant term, it means that you are multiplying with x power 0, where 0 is a whole number. Clear? So now these are all the polynomials. Right, now let us see which are not polynomials and why. See, 4x power half. 4 is a real number, not an issue. X power half, but half is not a whole number, therefore it can't be a polynomial. Now in this 3x square plus 4x power minus 1 plus 5. This is okay. This term is fine. This term is also fine because here is x power 0, 0 is a whole number. Here is x square 2 is a whole number. But when you observe here, x power minus 1 is an integer which is not a whole number, that is a negative integer. Hence it is not a polynomial. And when it comes to this 4 plus 1 by x, which means that it is 4 plus x power minus 1 again minus 1 is not a whole number. Hence even this is not a polynomial. So the next one is degree of a polynomial. Usually we define as the highest power of a polynomial is the degree of the polynomial. That we always call the name of the polynomial based on its degree. Okay. Right, therefore, how do we define degree? The highest power of a polynomial is the degree of a polynomial. Highest power in the sense, like suppose if you have number of terms, right, any one term will be having the highest power, right, that term is the one which is giving a degree to the polynomial, right. So the remaining terms which are having less powers, so those exist as terms in the polynomial, but they do not contribute to the degree of the polynomial. Right? Those who want just put a glance on the examples and the definition. Right? Also, you can note down if you really need it. But anyhow, this is a revision topic. Now, understanding degree of the polynomial, if there is only one variable or if there are multiple variables. See, only one variable means each term will be having only one particular variable in it. Even I say that a constant term has the variable where the power of the variable is 0. X power 0 is 1. So here you can see that there is only one variable. Okay, forget about the constant term. Let it be constant always in order not to get confused with the x power 0. Now see, if you see the variable terms are only x. Right, here in this case, what is the degree? See the power here. Power here is 1. Power here is 0. Right, power here is 3. The highest power. That means the degree of this polynomial is 3. Degree of this particular polynomial is 3. Suppose if you have multiple variables, right? More than one variable, like a polynomial defined on x, y, and z. Here is a polynomial which is defined only on x. What just now we have seen is only p of x, which is a polynomial defined only in x, right? That's a function of x. And here you can see that the polynomial is defined on three variables, x, y, and z. Right? So x square yz minus x z cube plus ex. See here, if you observe like how to find out the degree of the polynomial. Right? When multiple variables are there, then you have to add the powers of those variables. You have to add the powers of those variables in each term and see that which term is contributing the maximum or the highest power. That is the degree of the polynomial. As in this case, you can see that the powers are square, 1, 1. That means 2 plus 1 plus 1. So this is 4. Now if you see that it is only 3, if you see that it is only 1. So therefore, what is the degree of the polynomial? This term is contributing to the degree whose highest power is 2 plus 1 is equal to 4. This is very, very important. Okay, this is very, very important. Right. So usually have to express the polynomial like a general form of a polynomial with one variable. See, p of x is equal to a naught x bar n plus a n x bar n minus 1 plus a 2 x bar n minus 2 plus so on a n minus 1 into x plus a n x power 0. That means here you have n plus 1 terms. See, starting from 1 till n. Right, and a naught is also there. So n plus 1 terms are there, right? So where the degree is of the highest one, that is nth degree polynomial, where here the condition is that a naught should not be equal to 0. Why? Because if a naught becomes 0, this cannot be the nth degree polynomial. It will become, the highest power will become n minus 1. So therefore, when you define this as the nth degree polynomial, see that the coefficient of x power n is not 0. So a naught is not 0, and as usual all the coefficients are real numbers and all the powers, that means n is a whole number, right? And when we speak about the degree of the general form of the polynomial, we can also conclude saying that if it is of degree n minus 1, then a naught is 0 and a1 not equal to 0. Just now we discussed the same. If the polynomial is of the degree 0 means only constant term exists. Is it not? Why? Because I said always when there is a constant term, in the sense that the power of the, means you have the variable there but whose power is 0. X power 0 is equal to 1. That means in the general polynomial, whatever we defined, from a naught to a n minus 1, all should be 0 and a n should not be equal to 0. That is for the degree of a polynomial of degree 0. That means only constant term exists. Right? Only constant term exists. Right. Now next, moving on to the next topic, value of the polynomial. Right. If we assign a value to the variable of a polynomial and then if you substitute that value in the respective terms, that gives you the value of the polynomial. See, here is an example. We defined a polynomial p of x is equal to x square minus 4x plus 3. Suppose if I assign a value to x, then wherever you find x, there you will substitute that value and you will get the value of p of x. Right. So let us see the example how it is solved. So here is x is equal to minus 3. That means we assigned a value to x. So we define that as p of minus 3. right? That means a polynomial with the variable value as minus 3. Then value of this is equal to, now substitute in the polynomial, x square minus 4x plus 3 was the polynomial. Substituting minus 3 in place of x, minus 3 whole square minus 4 of minus 3 plus 3. See, now you know how to solve that. 9 plus 12 plus 3, which is 24. So which means that value of the polynomial given by x square minus 4x plus 3 for a value of minus 3 is p of minus 3. We write it as p of minus 3 is equal to 24. This is how we give the value to a polynomial, right? Yes, very important. And remember, understanding the theory, digesting it, and then start thinking to apply it will take you to the utmost satisfaction whenever you are doing maths, and it helps you a lot in doing by yourself, right? So therefore, rather than solving a problem, first listening the theory behind it, understanding the theory in detail, right, and then recollecting all that whenever you look at the problem, and then looking into the concept, which particular concept does the problem fall under. So that is what very important. See, ఎప్పుడైనా మనం ప్రాబ్లమ్స్ చేయటం కంటే ఏ ప్రాబ్లం ఎలా చేయొచ్చు అని తెలియాలి అంటే ముందు మనకి థియరీ ఏంటి, ఆ పర్టిక్యులర్ చాప్టర్ యొక్క థియరీ ఏంటి, ఆ పర్టిక్యులర్ టాపిక్ యొక్క థియరీ ఏంటో మనకు బాగా తెలిస్తే అసలు ఎవరు ప్రాబ్లమ్స్ చేయక్కర్లేదు. ప్రాబ్లమ్స్ అనేవి రిపీటెడ్ మోడల్స్ ఉంటాయి, రైట్? సో వన్స్ వెన్ యూ ఆర్ వెరీ క్లియర్ విత్ థియరీ. అండ్ ఇంకొక విషయం నేను చెప్తున్నాను, డిఫరెన్స్ బిట్వీన్ ఎ గుడ్ మ్యాథమెటిక్స్ స్టూడెంట్ అండ్ వీక్ మ్యాథమెటిక్స్ స్టూడెంట్ ఏంటి అంటే, వీక్ మ్యాథ్స్ స్టూడెంట్ ఏం చేస్తాడంటే ముందు డైరెక్ట్గా ప్రాబ్లమ్స్లోకి వెళ్తాడు. సో ఆ ప్రాబ్లం ఎలా చేయాలో తెలియదు కాబట్టి దాన్ని టీచర్ ఎక్స్ప్లెయిన్ చేసినప్పుడు లేదా అదే మోడల్లో ఉన్న ఒక ప్రాబ్లమ్ను చూసి సేమ్ అలా చెయ్యడానికి ప్రయత్నం చేస్తాడు. అంటే ఏంటి అర్థం? అతను సొంత ఆర్టిస్ట్ కాదు, బొమ్మ కనపడితే గీస్తాడు చూసి. కానీ ఇక్కడ ఎప్పుడైతే థియరీ చదువుతాడో, థియరీ చదివిన స్టూడెంట్, థియరీ అండర్స్టాండ్ చేసుకున్న స్టూడెంట్ ప్రాబ్లం చదవగానే ఈ ప్రాబ్లం ఏ పర్టిక్యులర్ కండిషన్ కింద వస్తుంది అని ఆలోచించగానే ఆ కండిషన్ ఎలా అప్లై చేయాలో తెలిసిపోద్ది. అంటే అన్ని టెక్నికల్ స్కిల్స్ తెలిసిన ఒక ఆర్టిస్ట్ లాగా బొమ్మ గీసేసినట్టు ఈజీగా లెక్కలు చేసేస్తాడు. అంతేనండి డిఫరెన్స్. దట్ ఈస్ ద ఓన్లీ డిఫరెన్స్. సో థియరీ ఈజ్ ఇంపార్టెంట్. సో చాలామంది, చాలా స్కూల్స్లో చాలా టీచర్స్ కూడా యూజువల్గా పిల్లలు వినకపోవడం వలన పాపం వాళ్ళు కూడా ఏం చేస్తారు చెప్పండి, డైరెక్ట్ ప్రాబ్లంలోకి వెళ్తేనే వింటున్నారు మెజారిటీ ఆఫ్ ద స్టూడెంట్స్. సో లేదా మ్యాథ్స్ అంటే మాకు పెద్దగా ఇంట్రెస్ట్ లేదండి అని చెప్పేస్తున్నారు. అందుకనే పాపం వాళ్ళు కూడా ఏం చేస్తున్నారు, డైరెక్ట్ ఎక్సర్సైజు, ప్రాబ్లమ్స్, మోడల్స్ చెప్తున్నారు. సో అలా కాదండి, మ్యాథ్స్ అలా కాదు. మ్యాథ్స్ మనం ఎప్పుడైతే మ్యాథ్స్ ఏది, ఏంటి, ఎందుకు అని తెలుసుకుంటామో ఆటోమేటిక్గా మ్యాథ్స్ అన్ని సబ్జెక్ట్స్ కంటే కూడా ఈజీ. అన్ని సబ్జెక్ట్స్ కంటే కూడా మ్యాథ్స్ ఎలాంటిదంటే ఆల్ డ్రైవింగ్ స్కిల్స్ తెలిసిపోయిన తర్వాత చక్కగా స్మూత్గా హైవే మీద వెళ్ళినట్టు ఉంటుంది. అలా మనం ఫీల్ అవ్వాలి అంటే ముందు థియరీ వినాలి. ఓకే, రైట్. నౌ ద నెక్స్ట్ కాన్సెప్ట్ ఈజ్ జీరో ఆఫ్ ద పాలినామియల్. సి, వాల్యూ ఆఫ్ ద పాలినామియల్ ఏం చెప్పాం? whenever you take some value of x and substitute that, then if you get a value, then that is the value of the polynomial. If the value is going to be 0, if the value itself is going to become 0, then that particular value of x for which the polynomial becomes 0, దాన్ని జీరో ఆఫ్ ద పాలినామియల్ అంటారు, రైట్? దట్ మీన్స్ if you define some polynomial px, and for what value, suppose if for x is equal to 1, if you are getting p1 is equal to 0, then 1 is the 0 of the polynomial. That means that is the root of this particular thing. So in the other terminology we can also say that to be 0 of the polynomial or root of the polynomial, right? So usually root is the word what we got used to use in equations. Right. Now let us see the example in understanding 0 of the polynomial. P of x is equal to x square minus 4x plus 4 is the polynomial defined. Now by using trial and error method, you can find if x is equal to 1. So let me do it here. If x is equal to 1, my p of 1 is equal to 1 square minus 4 into 1 plus 4. So minus 4 into 1 is minus 4 plus 4, that means 1. So by putting x is equal to 1, I got the value of the polynomial to be 1. So therefore this is not the root or this is not the 0 of the polynomial. Right, now if x is equal to 3, right, so then 4p of 3 is equal to 3 square minus 4 into 3 plus 4, so that is 9 minus 12 plus 4, right, 9 minus 12 is minus 3 plus 4 is 1. So even for value for x is equal to 3, polynomial is not equal to 0. Therefore, even 3 is not 0 of the polynomial. So 0 of the polynomial ante ఏ value of x ki p of x 0 వస్తుందో ఆ value ni 0 of the polynomial అంటారు. Right? Now if therefore x is equal to 3 is not 0 of the polynomial. Now let us see x is equal to 2. Substituting x is equal to 2, you will get to 2 square which is 4. 4 into 2 is 8. Minus 4 into 2, therefore minus 8 plus 4. So plus 4 minus 4 plus 4 and plus 4 is 8. 8 minus 8 is 0. So for x is equal to 2, we got the polynomial value to be 0. That means yet x is equal to 2, polynomial is becoming 0. Then 2 is 0 of the polynomial. 2 is 0 of the polynomial. Right? Alright. So just... Alright, please do subscribe and share with your friends. Don't forget that, because always I feel like I should say it in the beginning of the class and most of the times I forget that. Alright, but it's my duty to remind you. Now let us see types of polynomials. Okay, right, see, based on degree of polynomial, we define the type of polynomial. Suppose if the degree is 3, right, degree of any polynomial is 3, we call it to be cubic polynomial. If degree is 2, we call it as quadratic polynomial. If degree is 1, we call it to be linear polynomial. Right, and if degree is 0, constant polynomial, is it not? So therefore now cubic polynomial example, x cube plus 2x plus 3. Here the power of x is 0, here it is 1. In this term you are getting the highest power to be 3, and I said here when degree is 3, we call it to be cubic polynomial. When degree is 3, that is called cubic polynomial. Example, other examples are 4x cube plus 6x square plus 7x plus 5. 5x cube only single term, right? It is only single term, right? And this is a monomial with only one term. If you have, it is also called as a monomial. If two terms are there, binomial. If three terms are there, trinomial, right? And here degree of the polynomial is 3, therefore it is called cubic polynomial. Right? The next one is a quadratic polynomial. Right? If the degree is 2, right? Degree is equal to 2, then we call that to be quadratic polynomial. Examples are here 2x square plus 5x plus 3, 7x square minus 4, 6x square plus 1. Even if you have a single term also, then that is something like minus x square. That is also a polynomial which is having a degree of 2. Hence it is a quadratic polynomial. Okay, right. The next one is a linear polynomial when degree is equal to 1. Degree is equal to 1 gives you the linear polynomial. Here the power, highest power. The only variable term here is 2x, that is the power of this is 1, therefore linear polynomial. And single term, it's a monomial and a linear polynomial, right? So that is 7x power 1, hence it is a linear polynomial, right? So just to try to put a glance on this. Right. The next concept here is relationship between zeros and coefficients of polynomials. See, usually whenever we talk about the coefficients, right, so you have that as a naught, a1, a2, a3 in general form of polynomial we have seen, is it not? The coefficients start from a naught, a1, a2, a3 and so on till an, right? So an is the coefficient of constant term, a naught is the coefficient of nth term, right? So now we are going to see about a relationship between zeros and coefficients of the polynomials. See, and also here zeros of polynomial. First of all, we should understand how many zeros can be there to a polynomial. See, degree of the polynomial defines zeros. Right, suppose if degree is 1, that means a linear polynomial, then you will get only 1 0. Right, and if it is a quadratic polynomial, you will get 2 zeros because the degree is 2. If it is a cubic polynomial, you will get 3 zeros. Right, so first thing is that you have to remember this in your mind. So now here let us take the quadratic polynomial, right, and see the relationship or find the relationship between the zeros and the coefficients. Right, if alpha and beta are the zeros of the polynomial, what does it mean? It means that p of alpha is equal to 0 and p of beta is also 0. That means in place of x, if you substitute alpha, you will get the value of the polynomial to be 0. And in place of x, if you substitute beta, then also you will get p of beta is equal to 0, value of the polynomial. That is the meaning of that these two being zeros. Yes. Right. So now let us define the polynomial, quadratic polynomial. This is the general form of the quadratic polynomial. Remember this please. Ax square plus bx plus c, all plus only. All plus only. This is very, very important. You will get to know why I am stressing at this point. Right. So suppose if you are given an equation like 2x square minus 5x plus 3. So what is b? B is minus 5. It is not 5. Why? Because quadratic polynomial you are defining the every term to be separated by a plus sign but not with a minus sign. So therefore if at all there is a minus sign, it means that minus sign is allotted to the coefficient, not to the term. Okay. Right. So ax square plus bx plus c is the general form of the quadratic equation. Where a not equal to 0, then only it will become a quadratic, is it not? If a is equal to 0, this term will disappear. Then it will become a linear polynomial, not a quadratic polynomial. So a should not be equal to 0 is the general condition for the general quadratic equation. So then x minus alpha and x minus beta are the factors of p of x. That means p of x minus alpha is equal to 0, x is equal to alpha. Right, p of x minus beta is equal to 0 or x is equal to beta. That means here we say that these are the factors, x minus alpha and x minus beta are the factors. Right, now let us express them as k into x minus alpha into x minus beta is your general form. Is it not? So, if this is the polynomial, this polynomial can be divided by x minus alpha as well as can be divided by x minus beta. So, therefore, this is how we will write as k into x minus alpha and x minus beta is the is a valid equation, right? Now, where k is a constant. Right, so therefore, ax square plus bx plus c can be written as k times of x square minus of alpha plus beta of x plus alpha beta. So what do we understand here is this is always sum of the roots. Right, what is b term? It is always minus of alpha plus beta. What is c term? That is a constant term. Constant term is product of alpha and beta. Right, so now apply k, distributing k on every term, you will get kx square minus k of alpha plus beta x plus k alpha beta. Many other times question will be asked like find a number of quadratic equations. At least 3 or 4 quadratic equations they will ask you to write. So then first of all you have to find once when the roots are given, right? So from the roots you will get this relationship and you equate this to this. Therefore, your general form of the quadratic equation will be k times of this one, which is kx square minus k of alpha plus beta plus x plus k alpha beta. Right, now the quadratic polynomials, how many you can write? Infinite quadratic polynomials you can write, but because k can take all the values. Right, so when k except 0, like starting from 1, if you say, right, k can't be 0. Remember that if k is 0, then quadratic equation doesn't exist. Right, so therefore k is equal to 1, k is equal to 2, k is equal to 3. When you substitute all that, you will be getting different quadratic polynomials having same roots alpha and beta. Having same roots alpha and beta. Okay, right, now comparing the coefficients here with this one, you will get a is equal to k, b is equal to minus k of alpha plus beta, and c is equal to k alpha beta. So this gives alpha plus beta is equal to minus b by a. What is the relationship between the coefficients b and a? Minus b by a is equal to sum of the roots alpha plus beta. At the same time, alpha beta is equal to c by a, the coefficient, the constant term c, and the coefficient of x square a. These two are related to the roots as product of roots is equal to c by a. Right? Please note down this while you are revising. This is a very, very important concept. So sum of the roots is equal to minus coefficient of x by coefficient of x square. Similarly, product of zeros is equal to, right, that is alpha into beta is equal to constant term by coefficient of x square. Okay. So now we are going to see the general form of cubic polynomials. Very, very important, children. Quadratic polynomial, you will have two roots. Therefore, we have discussed there with alpha and beta as the roots. Now here we are talking about cubic polynomials. Means how many roots we should have? Yes, 3 roots should be there. That is alpha, beta and gamma. We are naming them as alpha, beta and gamma. That is what are called zeros. 3 zeros are alpha, beta, gamma of a cubic polynomial. And the standard form of the cubic polynomial is ax cube plus bx square plus cx plus d. Here d is a constant term, c is a coefficient of x, b is coefficient of x square and a is a coefficient of x cube. And here what should be the condition? A should not be equal to 0. If a becomes 0, then this will become a quadratic polynomial but not a cubic polynomial. So care must be taken while defining the cubic polynomial that the coefficient of x cube should not be 0. Right, if alpha, beta, gamma are the zeros of the polynomial, then x minus alpha, x minus beta and x minus gamma will become the factors of the polynomial. So x minus alpha, x minus beta into x minus gamma are the polynomials, what do we say, are the factors of the polynomial. Right? Therefore, this polynomial can be written as some constant k into right, x minus alpha into x minus beta into x minus gamma. Right, let me change this as k. Right, so again by just writing the k value, k different values, you will get number of cubic polynomials, the number of cubic polynomials with the same roots or the same zeros alpha, beta and gamma. So what is that you got here is general form. You have to remember it as k times of, right, x cube minus x square sum of all the zeros. The coefficient of x square is minus of sum of all the zeros plus coefficient of x is sum of the products of I mean sum of the products of the pairs, right, alpha beta, beta gamma, gamma alpha, right, sum of their products. Right, this is again plus, this is minus, this is plus, right? And the last term is again minus. Alternate plus and minus will appear here, right? Minus product of all the three roots, alpha, beta, gamma, right? Alpha, beta, gamma. Right, so therefore what is, now comparing this with the general equation, right? General equation, you will get k, a is equal to k. Now b is equal to k times of minus k times of alpha plus beta plus gamma, right? So therefore b is equal to minus k times alpha beta plus gamma, and c is equal to k times alpha beta plus beta gamma plus gamma alpha, and d is equal to k times of alpha beta gamma, right? So this is the general form of the cubic polynomial and the relation between the zeros and the coefficients, right? So therefore by simplifying you will get this one as sum of the zeros of cubic polynomial is minus b by a, right? Sum of the product of the pairs of zeros, that is alpha beta plus beta gamma plus gamma alpha, is equal to c by a, and alpha beta gamma is minus d by a. Very, very important relations, dear children. Please, this one, everybody you write it down. Everyone you write it down, this one in your notes. That is going to help you in solving the cubic polynomials, right? So very, very important topic. Right. So you have another topic, in fact, that is called division algorithm. That means how a polynomial can be divided with the help of another polynomial. But 2021 May, especially in Telangana State Board, that topic is eliminated. Therefore, now I am not focusing on that particular topic. Is that clear to everyone? Okay, so then let me end the class for today, and please don't forget to subscribe, share, and also please like the video. If you like, please click on the like. Thank you for listening.